Hello, this is my homework 6 screencast. So for problem 1 is the one that I was kind of confused on, just because we're given the step change in the table showing how there's the input, and then to analyze, we use the PI controller equation, which is set up below. And then because of the set point changes in the step put out, the error becomes the E of S. And then substituting this into the PI equation gives a time domain expression, which shows that the controller output should have an immediate jump followed by a linear slope. The immediate change at t equals 0 comes from the proportional term, so we would use the measured change, given Kc is negative 0.52. And then we would use the slope of the plotted line to determine the integral term using slope 1 equal to the 2.5 kc over tau 1, which gave tau equal to 37.1 seconds. The negative value of the kc indicates that the controller is the direct acting. The main confusion that I had kind of in this problem was recognizing the initial jump, which is determined by the kc, while the slope determines tau. Since the proportional and integral terms influence kind of the responses and how they're done separately. And then for problem 8.4, there we examined the block flow diagram to determine the signs of the process gains, the appropriate controllers, just looking at would it be negative, would it be positive based on what's going on. The diagram shows the two sections of the process labeled 1 and 2 with a flow transmitter controller and a valve. And so thinking about how this responds physically, we would determine the sign of each process gain. In section 1, increasing the variable increases the measured flow, so the gain is positive. Section 2, increasing the variable caused the flow to decrease, giving a negative gain. After determining the process gain signs, you would consider how the controller output should respond when measured flow deviates from the set point. So if the flow increases above the set point, we want the controller to move the valve in the direction that reduces the flow. And then based on that, the controller in section 1 should be reverse acting, while the controller in section 2 should be direct acting. This ensures that the control loop always acts in the correct deviation of the system back to the set point.